All right, let's look at some mole, mass, mole questions. And these are questions that you're going to see likely on the test for Unit 1. All right, so the first one is a question: how many atoms are in 7.5 moles of element A? Well, first of all, it doesn't matter what the element is. A mole is always going to have 6.022 times 10 to the 23rds. So this one I answered is 7.5 times Avogadro's number, 6.022 times 10 to the 23rd. If you multiply that out, it comes out to 45.165 times 10 to the 23rd atoms. But we cannot write in scientific notation a number that is greater than greater than 10. Sorry, 10 or more. It has to be between 1 and less than 10. So I need to move that decimal place one place to the left. Okay, so that's what I did here. I'm going to move it one place to the left. And that's what we get here, 4.5165 times 10. And we have to add 1 to the 23 to get to the power of 24. So it's 4.5165 times 10 to the 24th atoms. And so we said 7.5 moles is what we measured. There should be two significant digits in this final answer. So the final answer should be 4.5 times 10 to the 24th atoms. Question number 2. How many grams are there in 12 moles of element X? And again, it doesn't matter what the element is. If we state that there's 12 moles, every mole is going to have the same number of atoms. So 6.022 times 10 to the 23rd. Okay? But in this case, what we're asking is if element X has an atomic mass of 20 and an atomic number of 15, how many grams would it be? Well, whenever we calculate the mass of a element or compound, we're looking at the atomic mass, not the atomic number. So we're going to ignore the atomic number. So I've actually given you more information than you need to know here. So to set this up, we have 12 moles of element X, and we're going to multiply that times the molar mass, which is 12 grams per mole, for element X. So we're setting this up over here, okay? And we set that where we have 12 moles over 1, 12 moles of X over 1 times 20 grams of element X per mole. Our moles cancel out, which is what we want. And we come up with 240, and I put over here moles, but that's actually incorrect, right? I should have put grams, not moles. So we have 240 grams of element X. Okay? Now, number 3, how many moles are in 400 grams of element C that has an atomic mass of 10 and an atomic number of 12? So again, in this case, I'm asking how many moles. The piece of information that I need is the atomic mass. The atomic number, I don't need this information. It's a good piece of information to have, but I don't need that to calculate how many moles I have of an element. So in order to do this, I'm going to take the grams of element C, and essentially what I'm doing is I'm dividing it by the grams per mole, but I set it up here where I have 400 grams, and I multiply it times 1 mole of element C over 10 grams, because it's 10 grams per mole. In this case, my grams are going to cancel out, and I'm going to put 40 moles. So for the next two questions, questions 4 and 5, we're going to look at a compound. So in this case, I've made a fictitious compound. So what would be the mass if there are 7 moles of a fictitious compound with the following formula: E4F6. So that means that For element E, there are 4 of them. Element F, there are 6 of them for each of the molecules. So how do we calculate this out? First of all, we need to know the atomic mass of them. So element E has an atomic mass of 25. We said atomic number 15, but we don't need to know this. It's a nice to know, but we're not going to use the atomic number in this calculation. Element F has an atomic mass of 30 and an atomic number of 20. Again, we don't need to know the atomic number. It's good to know, but we don't need that. So for each molecule, I'm going to calculate out the mass of 1 mole of that. So element E, we have 4 of them per molecule. And element F, we have 6 of them. So we're going to multiply both of these times their atomic mass, or molar mass. So grams per mole. So the 25, where did I get this? That's the atomic mass. And remember, the atomic mass for the mole of an element is always going to be grams per mole. So in this case, I have 20. I'm multiplying 4 times 25 grams per mole, and I'm going to get a total of 100 grams. So if I look at element F, in each molecule there are 6 6 of the F element. So I'm going to multiply 6 times its molar mass, which is 30 grams per mole, and I'm going to get a total of 180 grams for that. Now I'm going to add these two numbers together. Okay? And it's going to be 280 grams per mole. So let me go back to this for a second. What I'm figuring out over here is the mass in grams of 1 mole of molecule E4F6. And so I add up the molar mass of E and the molar mass of F in this molecule, and it comes up with a total of 280 grams per mole of E4F6. So I said we have 7 moles, so I'm going to multiply the 7 moles of E4F6 times its molar mass, which is 280 grams of E4F6 per mole. So I'm multiplying here, right? This is my moles, times the molar mass, which is 280 grams over 1 mole. My moles are going to cancel out, and I'm going to get 1,960 grams of the compound E6F6. So if I have 7 moles of this compound, it's going to have a mass of 916 grams. Okay? Number 5. In this one, we're asking how many moles of Z7, so this is another fictitious compound, Z7B5 are in 1,060 grams. So, and what information do we need to know? Well, element Z has an atomic mass of 40 and an atomic number of 17. But we don't need to know the atomic number for this. We just need to know the atomic mass. Element B has an atomic mass of 50 and an atomic number of 40. But again, we don't need to know the atomic number to answer this question. So for each molecule, there are seven of the Z elements and 5 of the B elements. So I'm going to take that. I have my element Z. I have 7 of them, so I'm going to multiply times its atomic mass, which is the molar mass, 40 grams per mole, and that's going to give me 280 grams. So if I have 7 moles of element Z, I will have 40 grams. And in element B, if I have 5 moles, I'm going to multiply times the molar mass, which is 50 grams per mole, and I'm going to get 250 grams. I add those together, and it's 530 grams per mole of Z7B5. We said we have 1,060 grams of Z7B5, and I'm going to divide that by the molar mass, which is 530 grams per mole, and that gives me a total of 2 moles of Z7B5 in 1,060 grams. Something to keep in mind. Let's say we have water, H2O. So in this case, we have 2 hydrogens and 1 oxygen. If I have 1 mole of water, right? In every mole of water, I would have actually 2 moles of hydrogen. So 2 moles of hydrogen, and I have 1 mole of oxygen. So if I want to know if I have 1 mole of water, H2O, I have to calculate the mass of 2 moles of hydrogen and calculate the mass of 1 mole of oxygen. And I'll add those together, and that's how we get the molar mass for this compound. And that's actually what we're doing in the 2 previous problems. Okay, thank you. And if you have any questions, please contact me.